Everyone, this video is to go over multiple alleles blood typing assignment through Canvas. If you guys have questions after this assignment, please don't hesitate to email your teacher or reach out. So blood typing is different than Mendelian genetics, and there are several human traits, including blood typing, that are more complex and involve the interactions of more than two versions of an allele, much like codominance. For example, human blood type contains two variations of a dominant allele A, dominant allele B, and then in a recessive allele, little I. You're going to also see that in blood typing and multiple alleles, oftentimes you're going to see a superscript, okay? So big I, which stands for immunoglobulin A, and big I, big B. And then little I represents the recessive allele, where if you get two of these, you are type O blood. So just so we're clarifying as we are setting up these Punnett squares, if mom is big I, big A, big I, big B, and dad is big I, big A, little I, mom could either give the offspring big I, big A, or big I, big B. Dad could either give big I, big A, or little I. Okay, and these are the possible children if you were to set up that Punnett square. The next slide just goes over why are there different types of blood types? What is the reasoning and how do they work? Okay. And as always, the very first thing we're going to do when we set up Punnett squares is we want to go ahead and make sure we know and are confident in what are the genotypes versus what are the phenotypes. Okay. So each and every one of you has a blood type. It could be O, A, B, or AB. Okay. I am B positive, which we'll get into the RH factors of that positive or negative later on. I am a B. Okay. My husband is an O. Our son is either going to be a B or an O. And because I don't know if I'm homozygous or heterozygous, we don't yet know his blood type, okay? So the genotype for the phenotype O is little I, little I. So the only way you're going to be type O blood is if you're homozygous recessive, okay? With AB, you have to have an A and a B, and this is like codominance, okay? Both have to show up. Now with A and B, you can either be homozygous dominant or heterozygous, okay? Big I, big A, big I, big A is homozygous dominant, or you can be heterozygous, which is big I, big A, little I. This one right here is also known as a carrier for type O, okay? So as we're moving on, we're gonna go through a few problems together, okay? Again, always make sure you have some sort of phenotype and genotype chart written down for your own ease as you are filling this out, okay? So we have a mother with type O blood, okay? She is type O, so the genotype is going to be little I, little I. And she gives birth to a baby. The father also has type O blood, so little I, little I. What are some possible blood types that the baby could have? Okay. So this should be quick and easy. Mom is type O. So little I, little I. Dad's type O. Little I, little I. What are all of the offspring going to be? Little I, little I. Little I, little I. Little I, little I. And little I, little I. Okay? The only possible phenotype for these two parents are having a type O baby, okay? So for type O, 100% of offspring are type O, 0% are A, 0% can be B, and 0% can be AB. And as a reminder, when we're doing those phenotype and genotype ratios, even if it's 100% O, tell me the other possible phenotypes it could be and put those 0 percentages next to it. All right, let's do something a little bit more complicated. Here we have a mother that is homozygous for type A blood and a father that is homozygous for type B. And they have a child. And we want to figure out what are the percent for each offspring. Okay, so mom is type A. So she could either be big I, big A, big I, big A, or big I, big A, little I. I told you she was homozygous. So she is definitely going to be big I, big A, big I, big A. Dad is homozygous for B. So he's going to be big I, big B, big I, big B. Okay. So as a reminder, in order to do these superscripts, you can either go, let's do mom first, big I, big A, and you can highlight that and then go to, forgive me, format text, and superscript. Or you can simply do big I and then command period big A, I'm sorry. Command period, we'll take that as a superscript. Okay. So that's mom. Dad is big I, big B, big I, big B. So big I, big B. I'm going to just highlight that command period. Big I, big B. Again, command period. That's going to raise that up. And now let's figure out the offspring. Just like you're going to put the capital letter ahead of the lowercase letter, always put A in front of B because BA is not a blood type. AB is, okay? So here, get a, big B from a big A from mom, a big B from dad. So big I, big A, big I, big B. Let's go ahead and make these a superscript. Okay. All right. That blood type would be AB. All right. Now, big A, big B, again right here. Again right here. And again right here. So what percentage is type O or little I, 0%. What type is A? 0%. What type is B? 0%. And what type is AB? 100%. There is no way that they could have an offspring with any other blood type, okay? Now, let's go to another one. Here we have two heterozygous parents. So we have a mother that is heterozygous for type A, and we have a father that is heterozygous for type B. Let's fill out the Punnett square. So mom is heterozygous for type A. So she's going to have that little I. She's also known as a carrier for type O. So big I, big A, little I. Dad is heterozygous for type B. So he's only got one B and one little I. Big I, big B, and little I. Now we're going to see some differences among these children. So in this one, we could get big A from mom, big A from dad. B from dad, forgive me. All right, so that offspring would be AB. Now let's fill out this one. We would get a B from dad and a little I from mom. All right, that individual would be heterozygous for type B or a carrier for O. Here, we'll get a big A from mom and a little a from dad. Little I, not little a. Okay, that individual will be heterozygous for type A. And this individual, we're getting two little i's. What blood type is that? Type O. All right, so let's go through this. What percentage is type O? Little I, 25% or 1/4. Type A, heterozygous, still type A. 25% of those offspring are going to be type A. Here then, type B, heterozygous again, but we have 25% type B. And last but not least, 25% AB. Okay? Getting easier, right? Let's do a couple more as a class. All right, so here we have a mother that is type O and a father that is type AB. They have a child. Let's figure out their offspring's potential phenotypes. So mom is type O, so we've got little I, we've got little I. Dad is AB, so big I, big A, big I, big B. Big I, big A. Big I, big B. Let's see what their offspring are. All right, I'm going to get a big A from dad, a little I from mom. That blood type would be A. Here again, big A from dad, little I from mom. Again, type A. Here, big B from dad, little I from mom. And same exact thing for that last square. All right, so let's break this down. Are there going to be any type O babies? Little I. Nope. So that'll be 0%. Are there going to be any type A babies? Yeah, half of them are going to be type A. So that's 50%. Are there going to be any type B babies? Yes, 50% again. And last but not least, are there going to be any AB babies? Nope, none. All right. All right, let's do another one. A mother and father both have AB blood. Fill out the Punnett square and the ratio chart. All right, AB. That's big I, big A, big I, big B. Let's do it. Big I, big A, big I, big B. And the nice thing about this is once we have it, we can just copy and paste that for all of them. Because I know those superscripts can be a pain, but that's how we write them out. And you guys are all in science class, so we're going to write them correctly. Oh, my goodness. We got to separate these alleles. What am I thinking? So this is going to be big B, okay? We'll go ahead and copy that one, though. So dad's got big I, big B. Mom's got big I, big A, big I, big B. Okay, so now let's put these together. Mom will give a big I, big A. Dad will give a big I, big A. So baby's going to be big I, big A, big I, big A. So that's homozygous for A. That's the first time we've been able to see that. In this one, dad's going to give a big A. Mom, however, is going to give a big B. That individual is going to be like mom and dad, AB. All right. Here, we're going to get an A from mom, a B from dad, same exact thing. So we have an AB offspring here. Now, what is the only thing mom and dad could give us for this potential square? Big B and big B. All right, let's break this down. Type O. Any chance we can get a type O baby? Nada. Nope, we cannot. All right, type A blood. Yeah, 25% chance, and it's even heterozygous. What about type B blood? Same deal, 25% or 1/4. And last but not least, AB blood, 50%. You can double check that you did your ratio correctly. 25 plus 25 is 50, plus 50 is 100. Perfect. All right, last one I'm going to do with you, okay? A biology student is shocked to learn that although both parents are type A, she is type O. Is it possible she was adopted? Why or why not? Fill out the Punnett square. All right, let's talk about this. Even though you might be able to just talk it through, I want to make sure you also double check yourself using the Punnett square, okay? So both parents are type A and she is type O. So she is little I, little I. All right. Parents are either big I, big A or big I, little I. Is it possible if both of her parents are big I, big A, big I, big A, that she's their child? No, because there's no little I. However, is it possible that her parents are carriers for little I? There's a little I there. Could that show up in the offspring? Let's try it out. So if mom was big I, big A, little I, let's see what happens. Big I, big A, little I would go here. And if dad was the exact same, big I, big A, little I. All right, let's see. So if this was the case, big I, big A, little I. Nope, that wouldn't work. All right, let's try again. If we put this together, big I, big A, little I again. Okay, let's try this one. Big A, big, so far, let's see. What are we going to get? No, but look at this. Little I, little I. So she could be the child. She could absolutely be the child. But in order for her to not be adopted, her parents would have to be carriers for type O blood or heterozygous. So could these be her parents? Heck yes. The parents would have to be carriers for heterozygous to be her parents. All right. This last one I want you guys to do on your own. So you're going to help me figure out a who's your daddy case. In a paternity case, both a child and a mother are AB. What blood type will the man have to be to prove he is not the father of the child? Figure it out on your own. Submit this as a cloud assignment. And if you need help on this problem, just set up office hours. Thank you so much, everyone. Bye.